This section, we're going to talk about expected value. So what's the expected value? Expected value is average gain or loss if you're playing repeatedly. So it had to be playing many times, not for the one-time games, right? So if you're playing 100 times or 100,000 times, the average gain and loss is going to be your expected value. Kinds tell you how fair the game is, right? So if we're looking at the example 1, we're talking about the roulette games. In the roulette games, you're going to have 18 red. You see the red numbers, 18 red, black, 18 black, and 2 green space. And then if you pick one of this number to bid $1 and you end up winning, you're going to receive the $35 plus the $1 that originally that you paid. You're getting that money back also, right? Or if you lose, you're going to lose that $1 you bet. With that in mind, they were asking how much money should a player expect to win or lose if they play the games repeatedly. So again, they wanted to know what's the expected value of this game. So the way that you're going to figure out the expected value, you're going to know what outcomes you have. So let's say depends on the outcomes you have, that many times you're going to add them with the outcomes times the probabilities. So you need to find out the outcomes and the probability of that outcomes. So playing the roulette, you're going to have 2 outcomes. You're either going to win or lose. When you win, you get $35 because this $1 was your money that you bet, right? Or if you lose, you're going to lose that $1 that you bet, right? It will be $1. So probability of winning is going to be that one number out of total of 38, right? The 38 space. And the lose is going to be 37 out of 38. So in order to find the expected value of this event is going to be 1/38 times amounts of the winning, right? Plus 37 out of 38 probability times the amount will be -$1, right? And this gives you somewhere close to 0.9211, and this is going to be -0.9737. When you combine, you end up getting -0.053. So that's your expected value, -0.053. It means that negative means you're going to lose, right? So if you play this repeatedly, then your average lose is going to be $0.053. That is what expected value is. What about if we're looking at one more problem? It's a 40 years old man in the U.S. has a 0.242% risk of dying during the next year. An insurance company charged $275 for a life insurance policy that pays $100,000 death benefit. What is the expected value for the person buying the insurance, right? So again, expected value. This case, you can figure this one out with the repeatedly because it's not just the one person buying when you're looking at it from the insurance view, right? So let's see how we're going to find the expected value. Again, we need to figure out the outcome first. And we also need to know what will be the probability of that outcomes, right? So first outcome is actually making that $100,000 benefit. But then that $100,000 is not actually $100,000 gain because you spent $275 to buy it, right? So actual amount of gaining is going to be $99,725, right? That's a gaining. Able to get the benefit of the policy, right? Or what about if you don't get the benefit after you paying $275? You're going to lose that $275, right? And what will be the probability of it? Well, it shows that it will be the percent right here, right? So when you change that to the percent into the probabilities, it will be 0.00242. It means the other case is going to be 1 minus 0.00242, which is 0.99758. So your expected value is going to be multiplying the outcomes amount times the probability and plus the other outcomes amount times the probabilities, right? So you will do 99,725 times the probabilities plus negative 275 times 0.99758. This gives you around negative 33. So this means your expected value is losing about $33.